Welcome to The Explainer. Today, we're diving into a really fascinating question. Why do the super complex mathematical models that run everything from space missions to the stock market sometimes fail? And when they do, why do they fail so spectacularly? This quote right here really gets to the heart of the whole issue. Think about it. In physics, gravity is gravity. It works the same way every single time. But in finance, the so-called laws are based on human behavior, which, as we all know, can be rational one minute and, well, not so rational the next. That single difference is a huge reason why financial models can go so wrong. It might sound like a weird connection to make, but believe it or not, the exact same kind of critical thinking error that brought down a space shuttle is a problem that shows up again and again on Wall Street. To really get how this works, we need to start our story not in a bank, but on a freezing launch pad in Florida. So let's go back in time. January 28th, 1986. The whole world was watching, and then, in a horrifying moment, the Space Shuttle Challenger broke apart just 73 seconds after liftoff. All 7 crew members were lost, and the investigation eventually traced this massive, catastrophic failure back to something surprisingly small. The culprit was a simple rubber seal called an O-ring. Now here's the thing, the models used to approve the launch were all built on data from previous launches, which pretty much all happened in that typical warm Florida weather. But on this one fateful January morning, it was unseasonably, dangerously cold. And this right here is the key mistake. It's got a fancy name, extrapolation, but all it really means is you're trusting your model in conditions it has never actually seen before. The engineers basically assumed the O-rings would work fine at freezing temperatures because they worked fine when it was warmer. It was a fatal assumption. Now take a look at this data. This is the actual data the engineers were looking at from previous successful flights. Notice the temperatures? The lowest one on the chart is 53 degrees Fahrenheit. The temperature on launch day, a bone-chilling 29 degrees. They were operating completely outside of their own data. They were flying blind. So, if a model that's built on the hard laws of physics can fail this catastrophically, what on earth happens when our models are trying to predict something as wild and unpredictable as human economic behavior? Well, it turns out that most of the time, it boils down to one of these 3 things. First, the model is specified incorrectly. This means it's just built wrong from the get-go. Its map of the world is flawed. Second, it's used incorrectly. Here, the model might be totally fine, but the person using it makes a mistake. And third, and this is the big one for the Challenger story, it's used inappropriately, taking a perfectly good model and using it in a situation it was never ever designed for. All right, let's bring this into the world of finance. And boy, do we have a great first example. Back in 2021, some of the smartest, most sophisticated models on Wall Street were brought to their knees by a bunch of everyday people on the internet. You see, these giant hedge fund models that were betting against GameStop stock, they were all built on one core assumption, that investors act rationally based on a company's fundamental value. But thousands of individual investors weren't playing by those rules at all. For them, it was about community, about memes, and about pushing back against Wall Street. So what was really going on? Well, according to research by Yil and Zhao, it was a total perfect storm. You had people stuck at home with stimulus checks, you had these new, super easy-to-use trading apps, the market was already all over the place, and crucially, you had social media sites like Reddit creating this powerful, coordinated force. The old models were specified incorrectly. They just had no way to account for this new kind of reality. Okay, so what if you have all the data? You'd think that would solve the problem, right? Well, let's talk about Zillow. They had arguably the best housing data on the planet, and they built a model to buy and flip houses for a profit. It was a strategy called iBuying, and it backfired in the most spectacular way. They didn't just lose money, they lost hundreds of millions. Get this, towards the end, they were losing an average of $80,000 on every single house they sold. How was that even possible with all that data? It turns out their model was blind to some basic real-world stuff. It totally underestimated something called liquidity risk, which is just a fancy way of saying it takes a ton of time and money to fix up and sell thousands of houses. Not only that, but the model didn't even seem to realize that its own massive buying spree was driving up prices. It was creating the very bubble that was about to pop in its face. And this brings us to another one of these unseen forces, moral hazard. This is a super important idea. Think of it like this. If a huge bank takes a massive gamble and wins, they get all the profits. But if they lose so badly that they might collapse, they might expect the government to bail them out. That creates a crazy incentive to take on more risk, because they don't have to bear the full cost if things go south. And this is a huge headache for regulators, as research from Christian Hott points out. They've got a couple of tools to fight this. They can try to limit a bank size, or they can force banks to hold more of their own money as a cushion for riskier bets. But here's the catch. Both of these strategies have their own big weaknesses. It's this constant game of cat and mouse, with no easy solution. So, let's recap. We've got flawed models, unpredictable crowds, and these hidden incentives like moral hazard. But these failures rarely happen one at a time. The real danger is when they start to connect and snowball into something much, much bigger. Right, the problem isn't just one company with one bad model. The real nightmare scenario is when lots of different companies are all using models built on the same flawed assumptions. Then, when a shock hits the system, they all fail at once. And that's when the dominoes really start to fall. And the fallout from that, it can be absolutely devastating. Economists like James Gerber have broken down these financial meltdowns into the major types you see here, from a banking crisis like what we saw in 2008 to a country's currency collapsing. And the really scary part is they often feed into each other, with one crisis triggering the next. So after all of these cautionary tales, from space shuttles to the stock market, what's the big lesson here? It's simple, but it's so important. We have to remember what models actually are. They are tools. They are a simplified picture of a very messy, very complex reality. They're a lens to look through, but they are not reality itself. So no, the answer isn't to just throw all our models in the trash. The answer is to be way, way smarter about how we use them. That means we need good, quality data to build them on. It means we have to be constantly testing them and checking their assumptions against the real world. And maybe most importantly, we can never, ever outsource our critical thinking and our human judgment to an algorithm. And that really leaves us with one final, crucial question to think about. Whether it's a financial forecast, an engineering plan, or even just our own personal assumptions about how the world works, every model we use has a blind spot. So the most important question we can ask is, what are we failing to see?